Okay, so let's start. This is going to be the first slide, I was told. Everyone, thank you very much for coming. Appreciate it. We're going to talk about NLP, natural language processing. One of the feedbacks I've received often is to speak slowly. I speak very fast. I will remember that throughout my 4-hour session. But if you feel that I'm speaking too fast, please let me know. I'll slow down.
We'll listen faster.
There you go. That's a good attitude. I like that. My name is, I have a long name, Karunakar Singh Reddy. I go by SK. I've done a few things in my life in software world. I'm a techie. The last activity I did was I sold my second startup, but my first AI startup in March of this year. What it does was it actually compares documentation and also ranks documents. And I've applied that solution for comparing job descriptions with resumes and also ranking resumes. So acquired by a Boston-based company. Now I'm jobless, kinda. I'm working on a different problem statement now. I'm trying to work on 2 different problem statements. One is on image processing, some sort of image processing plus text processing. And the other one is pure text processing NLP using, trying to solve a healthcare problem. I'm not sure how much you're aware of what's happening in the NLP world, machine learning and NLP. There's a huge amount of investments happening in healthcare. If you go to Mountain View, San Francisco, any tech company areas, you'll find lots and lots of startup companies. Even Redwood shows I've seen a bunch of companies working on healthcare using AI, especially NLP. So from that perspective, I think you've really picked a nice topic, NLP. Even though machine learning has been there, especially the models and the theory was there for the last 10, 20 years, the real momentum, I think, came in only in the last 5, 6 years for machine learning especially. And actually, let's say artificial intelligence came really picked up in the last 5, 6 years. But within artificial intelligence, if you look at machine learning, I would differentiate machine learning with NLP as machine learning focuses more on number processing, number crunching. Let's say if you want to predict the stock price of a company, not tomorrow, but next month, you can do machine learning. If you want to predict weather, you can do machine learning. If you want to predict how many of the customers you've reached out to as a retail company is going to be converted as a customers, that could be machine learning. But these are all processing numbers. I think I wouldn't say it's easy, but I think relatively easy for a computer to process. But NLP, natural language processing, is processing text. I think we are all, you guys and me, we are all in that time in the technology world where NLP is evolving. It's one of the best papers published, which gave a tremendous boost to NLP, were published in 2015, late 2015. So I'll be talking about lots and lots of papers. So some of the wisdom, knowledge I've gathered from the papers, I will of course give the reference to those papers too, but all the solutions I'm going to talk about are from those papers. I remember when I was young, but I'm still young, but when I was still young, professors used to tell me that by the time some knowledge comes into textbooks, it would have, maybe I think 5 years would have gone by, or 10 years would have gone by, because I think they first get published in conferences, and then in tech papers, then maybe in magazines, then eventually maybe in the textbooks. So by the time, if there is a textbook available in any topic, that means the topic has been maturing for some time. You would hardly find a textbook in NLP. There are a couple of books though, by the way. There are free online NLP books available if you want to, but not in the way NLP is evolving today. You got a question?
Can you go back to the link?
The link?
Yeah. Yes.
So NLP is, from that sense, is really hot topic. People have not figured out how to solve it completely. There are so many solutions available today which are themselves being debunked every month, every day based on the new papers being published. But every time a new paper comes in, it's actually an improvement of a solution which was published earlier. I'm going to talk about the technology that appeared maybe 1.5 years or 2 years ago, and I'll talk about technology that appeared just 6 months ago to bring you up to speed. And I think when you're done for today, when you go back, and I'm guessing you will be able to start reading technical papers too. You know, in the academic world, I'm not from the academic world, but in the academic world, when people write papers, I was told the papers are not to educate others. These papers are only to show how smart and intelligent the author was. So you can't actually learn from a technical paper unless you know the surrounding information or the background information or some of the terminology, some of the concepts, some of the models, some of the approaches they talk about have to be learned from a different source, and hence you have to read the papers. But at the end of the day, session today, I think I'll equip you enough to go back and read some papers. And the real NLP knowledge is only in papers yet. You can't find anywhere else. Of course, you find a few blogs. There are really, really nice blogs available. I refer to some of those in my presentation today. But the best source, again, I know I'm branding myself. The best source of any blogs, you can go to my LinkedIn. There are a bunch of blogs I've written myself. From those blogs, they have given links to other interesting blogs in the world. I think you can go to that place too. And if you want to know my LinkedIn, this is my name and that's my email ID. Just in case if you want to send an email to me, that's my LinkedIn ID too. And if you go to this link, I have put all the Python files, and including this presentation is there at that link. So if you're able to download it right now, or if you want to download it later, you can still do it. But this entire presentation I'm referring to is in that, except whatever I modified in the last 24 hours may not be updated in that. But 90% of what I'm talking about as a PPT is there in that link. And if you have received these instructions earlier, a long time ago, I'm guessing at least a week or 2 weeks or 3 weeks ago, I had suggested to download these files. I had sent a zipped version of these files, but now these are available in this link right now. But I'll also send instructions for you guys to install. If you have not installed, it's not too difficult. You can go to NLTK.com, naturallanguagetoolkit.org, download that, and also you can download all the corpora available in that. It'll take maybe 1 or 2 minutes, depending upon how speedy your internet is. And if you have Anaconda Navigator on your machine, you would, I think, be taking care of all of those NumPy, Pandas, TensorFlow, Keras, all would be taken care of.
Do you have the notebook as well in your GitHub?
No, the Anaconda Navigator will actually give you a notebook, so you can open a notebook there. Okay. I can use any other notebook too if you have any other idea.
I thought you already have your notebook.
It's not notebooks, it's all Py files, Python files, yeah. You can actually open it using a notebook.
Is there free Wi-Fi here?
There is. I was told not to. That's only for speakers, but I'll tell you anyway. It's DBC5, GDBC5.
Enough to free internet.
Okay, free internet.
Yeah.
DBC5.
Yes.
Okay.
That's the name of the router, and the password is GDBC 2017. Yeah. Just don't tell them that I gave you that details. Okay, let's start NLP. As I mentioned earlier, I think in machine learning, I think it's relatively easier to process numbers. When I said relatively easier, it's not really that easy because you've got to have really good quality data and lots of data. But that applies even to NLP also, natural language processing, where you're processing text. You've got to have good quality text data to make sense out of it. What sense am I talking about? Let's talk some use cases. Huge investments are happening right now in healthcare. And any startup company in AI and healthcare using NLP, they're trying to solve the problem of how do we extract wisdom from the structured reports and the unstructured reports of patients. When I say structured reports, let's say you go to a lab, you go for a blood test, a urine test, you actually have a standard template and you actually talk about what's your RBC, WBC, calcium, iron, magnesium in your thing, and all of the other chemical names and the details and the standard limits of those numbers. That's sort of a structured report, even though every lab will have their own structure, but nevertheless there's a structure. But the unstructured report, which actually has 80% of the wisdom or the knowledge about the patient, and that unstructured reports are the narratives that the doctor and the patients have, the conversations the doctors and the patient have, which is captured by the doctor. So let's say if you go to a doctor for an appointment, is asking a bunch of questions, you're answering, and you're talking about family, you're talking about kids, you're talking about your lifestyle, you're talking about your eating styles, you're talking about your family history of any diseases like your parents, your siblings, or kids, whatever, and then you talk about overall your personality too. Where are you in a happy mood or in a bad mood? Are you going through some troubles at work or family? All of that information maybe I think would be discussed, and then doctor is doing two things. One is either he's typing constantly. If you've not observed it, you want to see doctor is he's talking to you, but he's typing because I think many of the doctors are supposed to capture that conversation. Sometimes they're doing an audio recording of it, and in cases when there's an audio recording of it which needs to be also transcribed, many times a medically trained professional in the background, maybe the same day or a couple of days later, will listen to the audio and then transcribes. There are a lot of startup companies working on that, where how to transcribe the audio part into text, and there's lots of issues of accuracies. I'll talk about one solution which is not yet in the technical papers, but if anyone of you guys interested in starting up your own tech company and trying to do a healthcare solution, you want to think about that idea, about how to bring the accuracy of a transcribed text from audio to text to 100% or 99%. Right now, the most versatile transcription tools available are anywhere between have an accuracy of between 80 to 90, 91, 92%. And 80% accuracy is okay in cases where I think you're doing the contact center or support center, where I think some missing or erroneous words in the entire text I think is fine. But if you're talking about a regulated industry like a healthcare, or if you're talking about the security systems or maybe the court systems, I think where accuracy is absolutely important, I think there are research. I think there's research going on how to make it 100%. So even if you have the text available, how would you find the right answer? Let me give an example to you. Within NLP, there is a section called question answering, and I'll talk about question answering too, but I'll give an example right now. Let's say that I give you a story and you ask the computer a question based on the story, and the story is the following. Sally went to the kitchen, John went there too, it was bright day in the morning, the weather was, 70 degrees, and Sally said a hi too. And if you ask a question to the computer, who is Sally saying hi to? For us human beings with our regular natural language processing skills, we would know that Sally is saying hi to John. But nowhere in the text, in the story, I mentioned Sally is a human being, and I did not mention John is a human being. Typically, I think a human being says a hi to a human being, I'm guessing. And I never mentioned John is in the kitchen. Sally went to the kitchen, John went there too. So computers have to comprehend the text and try to find an answer. And that's where NLP is coming into picture, of how to teach computers to comprehend or how to make sense of this unstructured data. I was talking to a CTO of a healthcare tech company. He gave an interesting situation in that unstructured report of a patient. I thought I'll ask you guys too. A doctor is talking to a patient, and the patient says, no, I'm not an alcoholic. And doctor writes, patient denies being an alcoholic. Okay, now you are the tech NLP guy, and you've got to make sense out of the statement and tag the patient as an alcohol, not alcohol, no information. Okay, so based on this statement, where the doctor says patient denies being alcoholic, what do you think is the patient? Using your natural language processing skills, what do you think? What's your interpretation?
Patient is alcoholic but denies to be.
Sorry?
Patient is alcoholic
but denies to be. Okay, that's one interpretation. Yeah, you had a comment?
Oh, I would say that the patient is not an alcoholic.
It's not an alcoholic. Okay, yeah. So you have two opposite opinions. Perfectly fine. Any other opinion? Or you can say, oh, maybe doctor doesn't know, because he's just asking the patient. You have to do tests because you got to make sure that the other person is not. But anyway, I think the interpretation was that the patient denies being an alcoholic means doctor is saying he is an alcoholic. For sure, he's in denial. So the two different messages coming out of that simple statement, which is not possible to comprehend if you just do a pattern matching of English text and you process such text. That's where NLP comes into picture. So that's one use case. Second use case can be, let's say you're a big massive company, tech company, you have good number of products and you have lots and lots of literature on the products available for the last 5-10 years, and you are training your sales guys. Sales guys may stay for the company for a couple of years or move on or whatever. So you have relatively young, new sales guys and girls. And if they have to be trained on all the products and all the variations of the products and all the history of the same product over a period of time, you may not be able to do the training, but you already have lots of documentation. But how would you have such salesperson sitting in front of a customer suddenly has a question, and then instead of asking a senior, experienced, long-timer in the company, hey, tell me 5 years ago we had a product ABC, was this feature in that product? And in that case, have you seen such a bug in the product? The customer is asking if they had any problems. And if the institutional knowledge is already gone through people leading the company, then you will not be able to find the answer for that question. But NLP can help you in processing massive number of documentation, and if you ask a question, again going back to question answering as a subtopic in NLP. Summarization, if you have massive amount of text, and if you want the model to tell yes or no for a question, or if you want to summarize it in a very short, a few words, then summarization is another topic which you can solve using NLP. So there are so many use cases in NLP. So you are actually sort of pioneers, I think, in this topic. The mere fact that you're here, because NLP is evolving right now as we talk about it. So I think I mentioned to you earlier. So these are some of the tools I would want you to install. But if you don't have that, that's fine. I will show it on my machine and process it. Some of you guys came. You're Greg, right?
Yes.
Greg. This is a link, GitHub link, if you want to download some of the Python files, and my presentation also is right there if you want to download it. Not today, but some other day also if you want to download. I'm going to keep it for the next 2 or 3 weeks up there. Some more problem statements in NLP, like word sense disambiguation. When you have a sentence written, like for example, let's say, the lost children were found by the searchers. The lost children were found by the mountain. The lost children were found by afternoon. When say, NLP has to figure out the last sentence, C, the lost children were found by the afternoon, it's talking about a specific time. It's a temporal aspect of the message in that. Whereas if you go to the first one, the lost children were found by the searchers, it's talking about a subject, an agent who's found them. And trying to make sense out of that and tagging accordingly is what you can do using NLP. The most confusing thing is the pronoun resolution. The thieves stole the paintings, they were subsequently sold. Who's the they? And the same day, the thieves stole the paintings, they were subsequently caught. The first day and the second day are referring to two different objects or subjects. They're not the same. And when you tag that sentence, and if you ask the NLP model to say, okay, the thieves stole the paintings, sentence A, thieves stole the paintings, they were subsequently sold, it will replace the word they with the word paintings. But if you give the same sentence in the second instance, the thieves stole the paintings, they were subsequently caught, it replaces the word they with thieves. That's the intelligence NLP brings to the table, and that's what I think you're going to solve the problem. Question answering, I gave an example already with the Sally going to the kitchen. Neural machine translation. Translation is another massive area of focus in NLP. You can have from text to text, but eventually I think there are a lot of audio to audio too, translation, but many times audio to audio translation of one language to the other language goes through the text to text and then becomes an audio. So the source language and the target language. you can do the translations. But let me actually go a little deeper in that. Translation from, let's say, English to German, English to French, you can have lots of corpus available. You can do a little bit of training. There's a lot of tagged corpus available. You can develop models, and then you can do the translation, which is relatively easier. But if you really want to achieve the true global village where you want all the people to connect and share and communicate and talk, then you need to be able to translate from any language to any other language. But the problem is, number one, the English and French and German, for example, they're very comparable. You have the subject and the verb and the object. They come almost in the same order many times, and there is again, almost word-to-word translation. There's a little bit change, but almost word-to-word translation. But if you translate from English to Chinese, for example, English to Japanese, the grammar, the sentence construction, the way you write is going to be so different. One of the most common problems in NMT, neural machine translation, is when you're translating, let's say you pick a word in a sentence, let's say the source language sentence, which actually has 10 words, and you're translating that into a target language, which may be, let's say, 5 words or 7 words. By the time you come to the 6th word or the 5th word, it actually refers to the first word or the second word in the source language. So the NMT model has to understand, when I'm translating, should I just pick first word and then do a translation of the first word and second word to second word? Or should I, when I do the 4th word, should I just go back and check what the first word was? Because sometimes the gender of the subject may impact the word that's going to come later. All of those issues are also addressed in NLP. Summarization, I think I mentioned to you earlier that if you have a good amount of text, how do you abstract it and make it even shorter using summarization? That's what I think this does. The NLTK, if you guys want to, after the session is over today, and whenever you have time, and if you don't feel like sleeping, this is a good source of sleep. You can start working on this and you'll fall asleep. NLTK has lots and lots of corpora. This is only a few I could fit into a screen, but there are, I think, 10 more. Each of those corpus actually has so much of data. If you look at the brown corpus, there are 15 genres and 1.1, more than 1 million words, which are tagged. You can actually play with it. There's lots of libraries available in NLTK. In NLTK, you can go to this website and download all the corpora. And if you want to play around with the raw text available there, and also using some of the libraries, this is a great source, and it should actually work for you. This is a large corpora, but I think there's a lot of more smarter and better have come. But for you to play around, if you really want, if you're a beginner or an intermediary in NLP, that's a good starting point for you guys to work on.
How does NLTK compare with like Stanford NLP?
They're all good frameworks. There are lots of libraries available, a lot of, I think, capabilities available in that. But NLTK actually has so much of corpus available. You can actually download this. Stanford NLP, I'm not sure how much of raw data is available. There is some data available, but I think I've not used it. I would rather prefer NLTK if someone is starting with. But there's lots of other data available. I'll talk about that. It's called Facebook Babby is a corpus of thousands of statements and questions. So especially if you're running a model for question answering, that's actually a massive data set which is tagged well. So if you can train a good Q&A model on that Facebook Babby that's actually created by Facebook. Microsoft has a bunch of data sets too, and even Google has a bunch of data sets. But I think for a beginner, I think I would recommend to start working on this. So let's say you have a text. There are a bunch of things that you can do to translate a raw text from the raw fashion to a stage where you can start working on it. At the end of the whole processing and a few more steps, you got to convert the text into a number. That's what I'm going to talk about. It's called how to translate a word into a vector, but that will be in a couple of slides later. But even before that, if you want to process the text and identify some wisdom in the text, especially in the healthcare, lots and lots of companies are becoming experts on these. For example, tokenize. If you have a sentence, John went to the movies today, if you want to break that sentence into just a word by word, it's just identifying each token. So if you have a sentence of 10 words, you actually have 10 tokens. And actually it will identify various tokens. That's the bare minimum first step you can do, how to break the sentence into a bunch of words. It's called tokenize. Normalizing. For you to process, you have a word at the start of a sentence with a capital letter, whereas in the middle of the sentence, the words are in the lowercase. Normalizing, typically, you try to bring the entire text into lowercase. That's another activity you can do using NLTK. Stemming is, I'll show an example of stemming in a minute, but you break a word, you take the word to its root word. Sometimes running is actually some variation of run. So you don't want running, runs, and such variations of the word run to be shown multiple ways. You want to stem it down and say, okay, we are talking about the word run there. And you can make more sense in the word run, but not the variations of the word run, by running or runs, runner or whatever. Lemming is almost very similar to the stemming part. Lemming is if any suffixes, let's say a plural, it takes out the plurality and similar suffixes it takes out. But stemming and lemming actually go together, where you are trimming the text and try to bring the words to its roots, try to eliminate unnecessary information. There's another word I think which is missing here. It's called stop words. In a let's say if you open CNN.com and then read a news item, you find the word like a, the, on, sometimes his, all of such words which are there. Typically, I think it could be 20-30% of the text could be such words, which are not carrying much of a message in them. So as an NLP expert, when you want to understand the text, you want to eliminate these words. Majority times it makes sense, sometimes it does not, but for our purposes, let's say, it makes sense to eliminate those stop words. So identifying those words which don't give much of a meaning in the context, those are called stop words, and there are standard libraries created in NLTK which will just one line of code, you can run it, and then you identify, you eliminate all the stop words. And let's say you want to customize that list of stop words, and you think, no, in my context, because the his and her are important, so I want to keep those stop words, I don't want to eliminate those. You can customize the set of database of the stop words, and then the tool will eliminate the rest and not these two. Sentence segmentation.
Do punctuations come under stop words?
It actually takes away in tokenize itself. When you put tokenize, it will just remove all the punctuations.
Counts, right? Dot or a comma, that also adds to tokenization.
It will show, but I think you can eliminate that. You don't count it. You can also do. I have seen people using commas, even at the rate of, and hash signs, all also to eliminate in the stop words. But then you have to add. But I think the standard definition of NLTK may not have it. I don't know exactly 100%, but I think it does not have commas and periods as part of stop words. Yeah. You can add all of that too. Sentence segmentation, word segmentation are sentence segmentations. Let's say if you have a sentence of 10 words, tokenize will identify word by word. It just takes the words out and then shows you. Let me see if I have an example. Yeah. There's a word tokenization. You have a sentence called San Francisco-based restaurant, they said doesn't charge $10. In the tokenize, you identify each and every item in that, including the apostrophe, the San Francisco-based, because Francisco-based is one word because you put a hash there, a hyphen there, and then you have the rest of the word. So this is tokenization. Lemmatization and stemming is, if you read that, I'll give a minute for you guys to read the first paragraph and look at how it is lemmatized and stemmatized. This was not the map we found in Billy's Bones chest, but an accurate copy complete in all things, names and height. So this is lemmatized T was not the map we found in Billy. These are, you're trying to lemmatize and stemmatize to bring the text to its bare bones and then make sense out of those. So let me see, let's run this. Have you guys, if you have it, I have installed PyCharm, and this one, which is because it's a free app, it's the subscription is expired, so I open it all the time. It says you got to buy it. I said, okay, fine, next time. It opens up. What was the name of the file I said open? Tokenize. Do you have an Anaconda Navigator? You can open a notebook there, or if you have any other so here I've shown you download, import NLTK, and then after that download NLTK. If you have not done the download earlier, then you have to download it now. But if you already downloaded it, the software is already there in the machine, then I think it's fine. So what I'm going to do is I'm going to copy that text. And what I'm going to do is I'm actually going to do a pure tagging. Pure tagging is, I'll explain that in a minute. Let me first put it here. Let's talk about pure tagging. Sentence segmentation and word segmentation. So tokenize is actually identifying words individually. Sometimes sentence segmentation is you break one sentence or multiple sentences into smaller pieces, each piece being a collection of words which all make sense together. San Francisco Gazette, let's say that's the name of or let's say San Jose Mercury News. If that's the name of one entity, San Jose Mercury News, in tokenize it will be actually 4 different words. But in reality, that's actually one entity, one word. So sentence segmentation will identify that such noun phrases together, and it will put them together. So when you do tokenization, San Jose Mercury News reported today that it's going to rain. If that's a sentence, and if you say tokenize, it says San Jose Mercury News reported that today. And when you do a sentence segmentation, San Jose Mercury News will be one chunk, and that's also called chunking. I think we'll talk about where name phrase chunking is. It identifies all the name words together because they all make sense together. They go together. The Boston Globe, I think Boston and Globe are 2 different words, but and if they actually exist independently too. Boston is a city, and the globe is another object. But Boston Globe together will make a different, will have different sense. So sentence segmentation is identifying such chunks of words. Word segmentation is even sometimes within a word you actually break down into smaller pieces, and we'll talk about that a little later. When do you use word segmentation?
Does some of that happen because of like a frequency analysis? The words co-occur together more often than what
Yes.
would be random.
Yeah. So how does that? If your question is how does NLTK know that? Yes, actually developed the model based on bunch of text. Predominantly they would have used Wikipedia, And from the Wikipedia, it understands, okay, what of these words which go together. So in Wikipedia, out of the 3 million articles, there may be words, there may be an article on just the globe alone, there may be an article just Boston alone, but there may be a bunch of articles which will talk about Boston globe and the frequency and a few other factors. Taking into consideration frequency and a few other factors, it knows that Boston globe together makes sense because they're existing right next to each other. The probability of you referring to Boston globe as a city having a globe is less probability versus Boston globe being the name of the newspaper.
Would having one of the corporas that you talked about earlier, like that's like a news-themed corpora or something, would that help recognize like the Boston Globe is an entity?
The NLTK libraries, when they have created, they have already got that wisdom in the library. So the library already knows that Boston Globe exists together. But if, let's say, if you want to train a model that, let's take an example, healthcare, just to expand your question. There's one, before I even answering your question, let me give a data point which was a news for me too. I just only heard 6 months ago. English language has around 500,000 words. The vocabulary is around 500,000. Do you know the size of the vocabulary of medical world in English language? I'm not talking about Latin and the words derived from Latin or French, no. I'm talking about just the English words in medical world. 60,000? Okay, any other guess? I'm not going to charge you for guessing. Go ahead, take a guess. Yeah, 100, just 100, okay. 100,000?
100,000.
100,000, okay. Any other, just a random, give me a random number, because this is going to be an exciting thing. You'll be surprised with this answer. And I did not know myself too, but I just heard later on. 100,000? 10,000, okay. Any other number?
1 million.
1 million, okay. Yeah, I could see your surprise in your face when she said 1 million. Yeah, I was surprised too. 3 million. So English language, the common English language you and me speak has only 500,000 words.
Is that include proper nouns and trademarks?
Sorry?
Does that include trademarks and proper nouns?
All the words, yeah, all the words they use. Let's say if you're a doctor and if you're prescribing, if you're talking to a patient and you're writing a bunch of things, and so, oh, the patient has to go for COPD, cardio something pulmonary disease, CVPD or something. I learned it. That is actually an English word. CVPD is one word, which is, well, in this case, the example I'm giving is maybe a wrong word, but they actually have pulmonary something. That's an actually English word, which is not normally used in English in common conversation, but that's an English word. It's not even French or Latin or whatever.
So, I mean, it's an entity. USA is not a word, it's an acronym. So is USA a word?
Yeah. As a vocabulary in English language, that's a word. It's an entity, yeah, that's fine too, but it could be the name of a person. For example, it could be the name, let's say Boston. Boston is actually still a word. Well, actually, I'll take it back. You're right. Not the name. I'll take it back. Yeah, you're right. In medical terminology, some of the lab procedures or some of the tests they conduct are English words, and they are different words. You can argue that it could be a name because it's actually a test and a name. I didn't get into that argument, but what I was told is there are 3 million words which are used in medical parlance, which makes sense.
I would say terms.
Sorry?
Terms are entities. It's a superset. Many of them are not.
It could be terms and entities too, but yeah, for me, it's a word and it may be a noun, but that's a word which actually has a specific meaning. And let's say if someone says pulmonary dissolution or whatever, pulmonary, it actually means some deficiency. It also means some type of tests need to be done, some type of medicines need to be prescribed, some type of care need to be taken, some type of situation the patient is in. I think it refers to so much of information, so much of messages in the word. So that's a word. And for a healthcare solution using NLP, you would rather want to find that word and see what the message behind that is. And if it has so much of message behind it, identifying such words, even sometimes used as an acronym or a full word or maybe a shortcut word, let's say pulmonary something, it's just a PUL dot, which is a sort of an acronym used by the doctor, but an NLP model still has to make sense out of that thing. So the point I'm trying to make is, in the sentence segmentations, but otherwise too, I think going back to our question, if you have so much of vocabulary in that domain, let's say, I think airline industry may have their own different terminology, which is not normally used by regular people like you and me, or maybe not be used in the medical industry. But so every domain has certain terminology, certain vocab. And if you want to create a model which actually understands and identifies the right tokens, center segmentations, etc., then you've got to train a model in that domain, because then the accuracy of the model goes up. You can use some of the generic models available, but they may not perform as well. And that's the reason why I gave an example of medical industry, because you actually have 3 million words as opposed to just 500,000 English words. And if you run a free model available from NLTK on a medical terminology text, you may not have the accuracy what you're looking for. So that's one of the first problems many startup companies are facing today, because some of these libraries, even though they work intelligently, they cannot make sense on many of the words used in medical terminology, because I think those words the model never saw, and hence it cannot make a good prediction of that. Any comment?
Yeah, I was just going to say, I mean, so COPD, whatever it is, cardiac pulmonary obstructive, whatever the health disorder. I mean, basically, the reason you get 3 million is because it's an acronym to determine you get the cross product of, let's say, there are 10, 20,000 words that could occur, and you just take that to the form.
Sure.
Okay, the last thing would be a noun, the first thing would be
Sure. But at the end of the day, for a doctor, it is, yeah. I would not pay attention as much for how the word came into existence, but the mere fact that the word is there and actually makes sense and it's actually being used to communicate certain message, and doctors actually have to learn.
You have to understand it's statistically, it's an entity in some way, like Amazon statistically in popular phrase.
Say that one more time, sorry.
Amazon, like Amazon statistically in popular phrase, it's a word that carries significance as a unit.
Yes, yeah. So if you give a search and if you ask the model to do Amazon, it may get confused. Are you referring to the rainforest, or are you talking to the company? It may get confused. And then depending upon what domain you're using the model for and how frequently, even if the model is trained based on just Wikipedia, and let's say in the last 4 or 5 years, the number of times Amazon is referred to as this company, but not as a rainforest, if it's more, next time if you use the word Amazon, model automatically thinks you're referring to the company and not the rainforest. And it goes back to the question I think even Greg was asking earlier. It's sometimes statistics too. The number of times a word has been used, model thinks that's what is more makes sense for the model to use the word.
So how do we combine like named entity recognition and tokenizing with a knowledge base to be something probabilistic, so like a ranked list of these are candidates for understanding this with confidence. Because ultimately this stuff is not deterministic. Probabilistic, and you might jump into candidates and work.
Okay.
Like say you see Amazon in an unknown context.
Sure. There's a long answer, but let me try to. I'm jumping ahead myself. There's a slide actually for that. There is in NLP there is a concept called language model. In simple terms, I would have explained that later too. In simple terms, language model is you take a large corpus of text in one particular domain. And let me go back to the example of Wikipedia. You take the entire Wikipedia and train the model on, you create a language model on Wikipedia. Now, what now the Wikipedia model can do is, if you give an incomplete sentence, it knows what the next word is, and the next word is, and the next word is. Let me take an example. The cat sat on the mat. So you give an incomplete sentence, the cat sat on the. Okay? And the language model has to predict mat as the next word. That's the right word in our context. We know that's the right word. But it could be anything. It could be the cat sat on the table, cat sat on the chair, cat sat on the oven, cat sat on the car. It could be anything. So you train a language model using Wikipedia. Again, if you use a different corpora, let's say in the medical world, it may pick a different word, but let's say you only take Wikipedia. It gives a confidence number for each of the word in the vocabulary. If let's say out of Wikipedia's 3 million articles put together, if you eliminate all the duplicates and the stop words, etc., if the vocab comes to let's say 100K or 200K, current day NLP research, when you read all the tech papers, all the decoders have a vocab of not more than 50K words. The current GPUs, or even CPUs of course, but more of GPUs, if you run a model with a vocab more than 50K words, it runs into weeks to compile or create a model. But anyway, I'm giving a long answer. So if you use a language model, it will predict, and it's probabilistic there, it gives a confidence level, and then sometimes based on the corpora, what you train it on, it gives a maximum confidence level of one word. And it may, in this case, say the cat sat on the car, based on, because Wikipedia information, because the word, the car comes more often than Matt maybe. And then it picks the word car.
Yeah, but just take an example, if I say sell Apple below 520, it's a financial context, it's driven by the stock, if it isn't, I might actually be talking about Apple.
Mm-hmm.
And so what I need is like a ranked list of here's all the candidates possible ways to trace. And language models don't necessarily work on incomplete phrases, the input and stuff that people write on social media bulletin boards.
Mhm.
They only work on complete grammatically correct
Yes.
sentences.
The last point I'll take first. You're right, the current language models are, because they're trained for complete coherent sentences, that's why it works. But there is some research going on how to make sense out of emojis and other incomplete words, I think used in social media to see if it makes sense. But there are not free language models available for download for such sentence constructions. But having said that, I think you asked a question of, okay, how would you know the right word? The language model, based on what type of training it got, it will predict it'll give a confidence level for all the 50K words. Obviously, you pick only top N. That's actually a concept called beam search. I'm going to talk about it a little later, where you identify. Let's go back to the example. The cat sat on the mat. The cat, and if you ask the model to predict what the next word is, let's say it says sat, ran. Let's say, and if you are doing a top 2 words, the cat sat, the cat ran. Now, if you pick the first word, the cat sat, and based on those 3 words, it may pick a different word, the cat sat on, whereas the cat ran, if you pick the ran part, the cat ran, the next word is going to be towards or for, whatever. So it's actually an entirely different branch, based on what word was the first word and the second word and the third word. If you really want to be absolutely sure that your language model or the prediction of your sentence is absolutely correct, then you do all possible branches.
Yeah, but that's what I'm saying, you get combinatorial explosion. So ultimately, you don't want every possible interpretation of the word.
Yes.
You just want a ranked list that gives you the top 10 candidates for the entire sentence.
Yeah.
All the way down to POS tagging.
Yes, it does that. Language model actually does that.
Let's not be too far off the slide.
Yeah, language model does that actually. Yeah. POS tagging. Coming back to POS tagging. I don't know. Did I answer your question about the language model? You can do the training.
Domain.
Yeah, the domain.
Yes,
You
that
got
was
me.
great, thank
Yeah.
you.
Yeah. POS tagging is if you have parts of speech tagging. What are the various parts of speeches you can think about? Yeah, you can have. These are so many different tags you can think of. There's a noun. You have the noun singular, for example, desk. Noun singular plural, desk. Proper noun. So, in a sentence, if it finds, it actually gives a tag to each and every word. And this is required because when you give a sentence for the model to do a tagging, and then once you know what is a noun, what is a verb, what is an adjective, what is a proper noun, what is a plural noun, singular noun, all of these things, then you can actually start forming trees of a sentence construction where what is the subject, what is the object, what is the noun, what is the all the nouns which that go together, what is the verb that goes with the noun ABC, and that's how slowly you are actually helping the computer to comprehend the text. Okay, so we were talking about POS tagging, so let's run that. So going back to your question again, the NLTK library actually has some of the capabilities already available. So I gave this sentence, and now for something completely different, if that's the sentence you're giving the model and asking, okay, can you tag it? It actually picks each word, almost like tokenizing, and then identifies a tag for each of that. And it's a millisecond activity. If you have your notebook and if you can run it, and if you have any questions, you can ask me. Any questions if you guys are running on the notebook? Yeah. And you can do a similar thing where, let's go back to So there's another example where you do a POS tag, which actually picks up all the words and then tags it. Again, if you want to run it, and then if you have any questions, let me know. There's another capability in NLTK which actually helps you identify similar words. When I say similar words, let's say you have a combination of three words. Example right there, W1, W, and W2. Let me give it a standard example. The cat sat. The cat sat. And if you want to find the word which are similar to the word cat that exists with the and sat together, it will run the entire corpus and gives you a list of words which are similar. So let's open the and this is based on the, I think, Brown corpus. Yeah. If you have downloaded the Brown corpus, I think it automatically picks up the information from there. These are the words, like for example, it ran a similar check on the word women, and these are the words that appear which are similar to it in the corpus given. And again, similar means if you have a three-word combination of W1, W, and W2, and if you want to find words similar to W, which exist with W1 and W2 in the same fashion as they exist, these are all the words that exist. So you can do a lot of manipulation on the text to run and identify and look for information what you're looking for. And and slowly you can. So, for example, you can use this to identify in the patient records of maybe similar patients with the same condition, or maybe you have a condition which actually is explained in multiple words, and if you want to find similar conditions that exist in the same report over a period of time, it could be any such reports you can do, and that's what you can do using NLTK. But again, as I mentioned to you, NLTK is one of the older models available. There are so many new models available too. You can use those, but for your playing, you can use this.
Can you explain once again how does it determine similarity?
How you mean how? It's a built-in API in the library. It just goes and looks at the whole corpus. It's actually brown corpus. I think it's a bunch of, if I remember correctly, I think there's lots and lots of electronic storybooks, novels. So it does it efficiently reads the entire text, do a pattern matching, and the pattern matching it's looking for is, let's say if the pattern is W1, W and W2, the W is the word you're looking for. Like I said, the cat sat, and the word is cat for you. And if you want to find all other words that appear in such a way that the word before that is the, and the word after that is sat, it will identify all the words which will appear in the same fashion, W1, W and W2, to the word similar to the word W. So wherever the same combination appear, it picks up. It's more of a pattern matching right here, but I think this is an efficient algorithm. It actually goes into the entire corpus. Even if you have, I think, I don't know, a million word text, it actually can do it in such a short time. So if you want to, this is used with a little bit of variation. You can use this to identify such pattern in patient records and stuff. This is an example of stop words. Okay, let's actually run that too. So there are some standard stop words in English language the model provides already, and you can, these are all the stop words, and as I mentioned to you earlier, the definition of stop words are, these are grammatically required words in a sentence, but they actually don't carry much of a meaning that is required when you're doing the analysis. And actually, I think it has lots and lots of these things. You can actually go into the database to update them if you want to eliminate a few or add new. And there's an example for stemming also. I'll skip that. Viewers tagging. I have this is actually a fun thing for you guys to do. Even though this is not pure NLP, this is some sort of a classifying of sentiment. It's a little bit of NLP, but not pure NLP. So go to your IDE, open your classifier. There is a file called tweets.csv, which is part of the list of, it's right here. It should be in your library, which I had asked you to download. And if you don't know what it is, let me open it. So these are the various tweets about a product. I think it's an Apple product, I think iPhone, I guess. And then this is actually tagged. So if you look into, if you open your file, this is not sorted. I just sorted it to show how many are tweets with a negative emotion how many are with no emotion mentioned, and then I think if you go all the way down, there's some positive emotion. So if you give this data set to the model, it reads each and every tweet, starts making sense why something is positive, why something is not positive, why something is there's no emotion. After you train the model and then you say, okay, now I'll give you a new tweet. Can you tell me this is positive or negative or no emotion? It'll actually tell you. But there's a fun factor in that, which if you guys want to run it, so let me run that. So I have this entire file here, the actual code. And here are the 3 tweets I put it. This is fantastic, extremely bad, iPhone costs too much. Okay, there are 3 tweets. And it's a little funny. So let me remember the 3 tweets. Positive emotion, no emotion, negative emotion. So these are the, okay, this is fantastic, extremely bad. It is definitely a negative emotion, but it says no emotion toward brand or product. It's because you have not mentioned the product, their name. Maybe it's thinking that you're not talking about the product, you just say talking about something else, and hence I think it's not picking up. iPhone costs too much, negative emotion. Now, if you have this running up on, just play around with that. So let's say this was one example which I was smiling to myself. This sucks. Definitely is a negative emotion, right? Okay, watch. It says positive emotion. So why? Why is this giving a wrong information, a wrong analysis? Because this is what I think is going to be a major issue for machine learning or even NLP, any of these problems. I think if you go to any startup company or any solution looking for, all research people are working on right now is how to bring the accuracy rates of your models higher and higher. Right now, I would be very surprised if someone says my model's accuracy rates are 100%. I don't think, of course I'm not a really smart guy, but whatever little I know, I don't think there are models that exist which are 100% accurate. What contributes for the inaccuracies of the model? I'm jumping ahead, but I just want to show this as an example that the models, I think, there's a lot of effort goes into improving the accuracy. Getting a 80%, 85% accuracy, sometimes even 90% accuracy is relatively easier with a little bit of activity. But I think bringing that from 90 to 92, 95, 97, 99, 100, I think is extremely difficult. And one of the most commonly repeated problem, at least until 6 months ago, a year ago, was you need to have enough data. You need to have really large amount of data, and preferably good quality data. There are some research reports, and I believe in them, research reports which are proving that you can create certain NLP models which are highly accurate, but with less data. But those are only far and few research reports, and it's not accepted by the mainstream. So one of the first things why this particular model I think is not showing accurate result is, let's go and look at the data. So total of, I think there are, if you look at the number of tweets, around 9,000. It's around, 9,000, 9,100. And in that, let's look at the positive emotion. So it's around 3,000. So there are 3,000 tweets you are giving to the model to understand what is a positive tweet. And none of the tweets are, if you read all these so-called positive tweets, they don't use consistently the same word for the model to figure out, oh, okay, if this word means it's positive. It doesn't happen that way. And now let's look at the no emotion are a lot. Actually, yeah. So almost 5,000 tweets are tagged as no emotion. So less than 1,000 of the 9,000 tweets are negative emotion. Also, it's not completely 1,000, it's actually 725. Also, not really, there are some unique tags like I can't tell, and there are some, yeah, so I can't tell if you express 156. So I think around 600 of the 9,000 tweets, only 600 tweets will tell the model that this is a negative emotion. And that is not sufficient for the model to figure out. Greg.
Is there some data sets that are labeled with sarcasm that help with accuracy?
Yeah. So, good point. So, let me finish this and then I'll come to, because that was my next point actually. If you don't have enough data, that's number one first. Second is if you don't have enough good quality data, number two. Number three, here let's say you're making a prediction of positive emotion, negative emotion, and no emotion. So this in machine language terminology is called classes. There are three classes in this. And typically for a model to be really a balanced model to give a decently accurate prediction, the number of data, the amount of data for each class has to be approximately the same. It has to be balanced. So if there are 9,000 tweets, I would rather expect 3,000 for one negative emotion, 3,000 for the positive emotion, 3,000 for no emotion, and hence that may be a little more balanced. And hence you can say the model is figuring out, even though 9,000 itself is not a sufficient number of data sets. Now, so these are a pure, you tagged positive, you tagged negative, and you tagged no emotion. Now, there are a lot of other emotions. A lot of companies are trying to figure out, okay, fine, I don't want just only the positive. I just don't want the negative. I want to find how positive or how negative. Sometimes I want to find out, is it really a positive? It's like a sentence. I loved the music, I loved the movie, except if you want to really get a headache. So you're actually putting a sarcasm in the thing. And if the word is looking for, I loved the movie and enjoyed it thoroughly, whatever, if you actually see such words first, and then some other maybe one word which shows headache, the model may not figure out that you're actually, even though you're sounding like a positive, it's actually a negative emotion. Sarcasm, indirection, double negatives. Sometimes, if you say I don't like this movie, versus I don't like this movie, I don't like this movie. If you give a basic rule in English like a double negatives is positive, then I don't sometimes if you can tell the model, okay, it may be positive because it's because double negative. But someone wants to really show, oh my God, I hate this movie, and that's why the person repeats, I don't like the movie. It's actually showing these types of nuances, sarcasm, anger, the depth of the intensity of the emotion, like the negative or the positive, etc. People are trying to find out now how to get the depth of it, and there are not enough strong models available which is figuring out that particular emotion. You can, if you have, let's say, instead of having a 9,000 tweets, let's say you have 1 million. If you go to my blogs, actually, I've written even a GitHub also. I have solved the problem in two different ways. One is sentiment analysis for a small database and sentiment analysis for a large database. Actually, I've taken a 10,000 tweet data set with just a positive and negative, and then I ran a model, and then it's available on GitHub. It's also available as a blog in my LinkedIn. But then I actually turned around and then took a 1.4 million tweets for sentiment analysis, and then and ran the model too. The accuracy went up only a little bit. From 10,000 data set to 1.4 million data set, actually went up, I think it was 75 or something in the first instance, and maybe I think 85, 90% I think in the second instance. But even then, 1.4 million tweets I think still was not sufficient for the model to actually figure out every new sentence, every new tweet that comes in to figure out exactly whether it's figuring out. Going back to your question, Greg, some of the nuances of sentiment analysis I think people are still working on, doing the research on. Some companies, I know some Indian-based companies, and there's some US-based companies which actually have some solutions for the sarcasm and the depth of the intensity of the emotion, etc. But Yeah, they're not figured out yet.
Can you do some normalization or something like that? That would be great. But,
What type of normalization?
you know, since you have the categories, one is 1,000, one
Mm-hmm.
is
Yeah. So then you talk about, I think, a different type of activity where data augmentation can actually increase the data or decrease the data. Instead of having, if I have only, negative emotion has only 1/6 of data, and only 10%, whereas no emotion has 40%, and positive emotion has 30%, then can I distribute? Yeah, you can synthetically enhance the data. There are a lot of techniques for that too. You can reduce the data so that you can actually have a good balance. Also, I'll give a unique situation. I think just on this example itself, which actually confuses the model very well. So I have 9,000 tweets here. You can actually run this model too at home. 9,000. Instead of giving 30%, 30%, 30% break, let's say for positive emotion, you make 90%. So eliminate all of the data and then keep the data, 90% data as positive and 10% as negative. Or actually 95% of your data, make it as positive emotion tweets and 5% are negative emotion tweets. And then you run the model. You give a new tweet and let the model predict. And then based on the new tweets, you actually start evaluating. So you run some metrics. What is the accuracy rate of my model? Even if you don't write a single line of code for your model, you can bring 95% accurate model. And how? Because the data set is 95% positive, every new tweet that comes in, just say it's positive. And you as a model, if you are the model is 95% accurate. But what's the model doing? It's doing nothing because you have not written a single line of code. All that you says, any new tweet come in, respond as positive emotion. That's it. Just one line statement, print statement, and that's it. The model, that's what is the model. But people say, oh my God, this is a 95% accurate model. The reason for that is the data is so imbalanced. So there's a huge amount of research happening. So if you guys want to become an expert in NLP, you want to really focus on that. The actual model development is almost trivial. I may be discouraging you when I say this. The actual NLP model creation and training may be a little bit of a trivial activity, but the data, what you're getting, is extremely important. 80% of your NLP projects effort will be spent on data collection, data collation, data cleaning up, data augmentation, whatever things to bring the data quality up. I was told at 10:20 there is a coffee break for the regular guys, and I think coffee is a good source of energy, I guess, I was told. So maybe it's a good idea to take a break. Yeah, you want to take a break, or you're so excited that you want to continue? Yeah, I'll tell you a quick story and then we'll take a break. You know, long time ago when I was, I love teaching, and I was teaching in a university, and first time, a young guy, I don't know what to even teach, even though I know the subject, I don't know how to teach. So I actually asked the professor, tell me, how do I make sure that at the end of the semester, people still like me? I said, make sure the students are engaged. And the moment they are not engaged, stop teaching, because it's of no use. I said, yes, that's a nice statement. How do I know they're engaged? I said, the body language. One, they're leaning forward, they have the pen and a pencil or the computer, they're typing, writing, looking at you, the facial expressions are changing constantly, they're engaged. Pens are down, laptops are down, and they're leaning back a little bit. Once in a while, they can change the facial expression. When you walk up and down, their eyes also move with you. They're semi-engaged. Ask a question, no response on the face, typically the hands are folded, leaning back, definitely disengaged. So I think it's time to take a break. Let's take a break and come back at 10:40. I don't know where the coffee is served. I just came for today's conference, so you need to figure out where the coffee is. And please come back at 10:40, and I'll see you guys here. So you should download the files I have mentioned here. the presentation and all the files are mentioned here. You can download that, and then there are some installation suggestions I had made. Maybe you can take a picture of this, and then you can download and install this during the break if you can.
Sure.
Yeah, so this is where you need to download all the files. Let me pause my video.